So for chapter 5, everybody, chapter 5 is about linear functions. It's still function stuff. Everything is going to be focused on lines. Okay? We should all have hopefully a notes packet. It's just going to be focused on lines. Okay? And I know this packet is a lot heftier than the previous ones, but there's a lot of graphs. Graphs take up space. Okay. Hopefully some of this stuff, especially today, is maybe familiar to you a little bit, especially if you had pre-algebra last year. Okay, that no matter what, even if it's like, well, I don't remember how to find this or that, but at least hopefully you've heard of these things, because usually we come into this not knowing any of it at all. Okay, but we are going to first talk about rate of change and slope, which is a big part of understanding lines. My posters on the back wall here are all about lines and slope and all that kind of stuff. Okay, just because I think it's pretty important to know. So, rate of change, the definition is up there or on your paper. It says a rate that shows how one quantity changes in relation to another. Okay, we'll talk about rate of change in here a little bit. You guys know what it is. You've seen those things out in the real world a lot. But that line there in the middle, that's not just a random line. Whenever we're talking about rate of change, whenever we're talking about slope, it always kind of comes back to we are doing or finding the change in y over the change in x. Okay, we will look at several ways to find things depending on what we're given from a table, from a graph, from some points, and it will look different depending on what we're given, but it always comes back to this. We're doing the change in y over change in x, okay, to find the rate of change or the slope. They're really the same thing. So if we look at this table, what do you notice about this table? Pattern-wise, maybe. Maverick, what?
The X is going in fours.
These are going up by 4s. Good. What about the Y's? Cole?
The X is Y does it 2 times more than X.
Yeah, so they're going up by 8. So, what would the rate of change be for this table?
4 over 8.
8 over 4. Change in y over change in x. So 8 over 4 or just 2 if we simplify, right? 2. It's okay if it's a whole number. So that is the rate of change for that table. It's just the change in your y values over the change in your x value. Now, for the majority of what we're going to do today, we're going to talk about slope. That's the next thing I have here. Slope is always the variable m. Okay, how or why or who did that a million years ago? I don't know, but slope is m. M is the variable for slope. By the end of chapter 5, we should hopefully, every time that we see the variable m, that should be what we think of, is slope. Okay? Slope is the steepness of a line. Okay, the number that you get for your slope kind of tells you how tall or how vertical your line is, or maybe how horizontal or flat your line is. Okay, we'll talk about that more as the chapter goes on. We're going to be more concerned, though, with that slope also tells us the direction. Slope tells us the direction a line is going as well. And we're going to use that just kind of to help us out, just to make sure things are going the way they're supposed to be, or our answer is the correct value. Okay, that's one of those things I use all the time, is the direction. So, from a graph, does anybody remember this? Find the rise over run.
I remember it, but I don't know.
Yeah, that's what I'm talking about. You've heard of it at least, even if you're like, I don't really remember it, but you've heard of it. So we're going to find rise over run from a graph between any 2 points. It's just up and over. That will tell us the slope of the line. So here's what I mean by that. Or I guess I should ask you. When I say between any 2 points, when I say a point on a graph, what am I talking about? Like, where's a good point on this line? Okay, so Caden said 0, 6. Good. Did you say one? -4. Say it one more time. Oh, I'm sorry. You said -4, 0, right? Good. Those are points. Are there other points on this line? Yeah. Obviously there are, right? But all you need is 2. And this is the nice thing about slope. You can literally pick any 2 dots that you want. And it should work. And now we're going to use rise over run. Always go from the lower point to the upper point. So I'm going to go from this lower point and go up and then over. That's rise over run. Up and over. How far up did I go there? How far over did I go? 4. So my slope is 6 6 over 4. The only thing we got to do is make sure we simplify or reduce. Can this be reduced? To what? 3 over 2. So my slope for this is 3 over 2. When we get to Math Excel, if you put 6 over 4 in, it will not count it correct. You have to get it simplified all the way. Okay, now, before we move on, I said here between any 2 points, right? Do you guys see this dot I could have put right there? What if I would have used that? Rise is 3, run is 2. It's 3 over 2. Even if I go all the way down here, way to the bottom, and I go all the way from there to the upper point, my rise here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My run is 1, 2, 3, 4, 5, 6, 7. My run is 8. I get 12 over 8. Guess what 12 over 8 reduces to? Divided by 4, and you get 3 over 2. Okay, so when you're doing these on your own, you can pick whatever 2 points you see first. I will give you a little hint strategy. I always try to pick 2 points that are as close together as possible. Okay, less counting and less simplifying. Okay, so like the showing you from the bottom way to the top, probably not the best way to do it. Okay, that's too much work. Okay, does anyone already like the next one over here? Anyone think they know what the answer is for this one or what the slope is for this? Yeah, anyone think they got the slope? Skates it up 4 over 1. So when I was looking at this line, excuse me, and you might be different, but my 2 points that I saw were this one and this one. Okay, if you saw a different one besides that, fine. That doesn't matter. So up 4 and over 1, correct? Now, we're a little bit, I don't want to say wrong, but kind of. It's not 4 over 1. Well, it's 4 over negative 1. Why would it be negative 1? Because we went to the left. Anytime you go to left on the graph, that means negative. So my slope here is 4 over negative 1, or just negative 4. Again, on Math Excel, if you typed in 4 over negative 1, it would not count it as correct because it's not simplified technically. Now, this is what I was talking about with the direction a line is going. The first one, we have a positive slope, correct? The line is going up to the right. The second one, we have a negative slope, and the line is going up to the left. That is always going to be the case for a positive and negative slope. That's one of the first things as we go through this chapter and you're working on stuff or you're graphing something, that's always the first thing I look at is the slope positive or negative? Is the line going that way? So like this one here, guys. Will the slope for this one be positive or negative? Negative. What about this one? Positive, yeah. So right away we know my answer for this one should be negative. The other one or the next one should be positive. Okay, why don't you guys real quick get the slope for both of those. Okay, at your tables. I'll give you like 30 seconds. Find the slope for both of those lines. Guys, make sure you're finding the slope, please. Okay, not trying to rush you, but that one there on the left, anybody have the slope for that one? Raise your hand, please. Anybody have the slope for that one on the left there?
2 over negative.
Right.
On the left.
Up to, left 5. Okay, now, for this one, we know this is a negative slope. If you type in or write down 2 over negative 5, that's fine, but you're not going to always see it that way. If one of my numbers is negative, I'm going to put the negative sign in front. That's a negative 2/5. So like if I would type that in, I put the negative sign first, then my fraction thing. So if one number is negative, it's just like the fraction itself is negative. Okay, what about the next one? What's the slope of the next one? What? Yep, you did. So there's my 2 points again, if you look up there, that I used. 3 over 1 or just 3 would be my slope for that one. Okay. All right, let's go to the next page. We do have quite a bit more here, so stay with me, please. Excuse me. What about, everybody, listen up, please. Horizontal and vertical lines. And we're going to look at those to see if those make a difference. So we're not going to change anything that we just did. We're going to do rise over run. So I'm going to pick 2 points. I'm going to pick those two. I know I could have picked like right next to each other, but the grid's kind of small and it gets kind of messy. So, all right, guys, pay attention. For this one, what is the rise over run? What's the rise for this? 0. What's the run? How far over do I go? Nope, I got to go over 2, right? Up 0 over 2. What's 0 over 2 equal? 0. Horizontal lines will always be 0. Doesn't matter where it's at on the graph. If you have a horizontal line, the slope is 0. So you have 2 choices. You can memorize that, okay, or you can just do rise over run and you'll get it anyway. Okay? All right, what about a vertical line? Same thing. Couple points. What's my rise? Guys, pay attention, please. What's my rise? 2. What's my run? What's that equal? Anybody have a calculator in front of them? Do 2 divided by 0 on your calculator and tell me what you get. Just do it on your calculator and tell me what you get. You get divide by 0 error. You cannot divide by 0. In math, that is not a possible thing to do. Okay? So, we say this one has an undefined slope. Hey guys, quiet down. Stay with me here. A vertical line will always have an undefined slope. Again, you can memorize that, but if you do rise over run, use your calculator to make sure you will still get it. So you can memorize it or just do rise over run, and you'll get it either way. Okay? But horizontal and vertical lines will always be that way every single time. All right. Now, next thing. Oh, sorry, yeah. Yeah, I get it. Okay, guys, if we have just 2 points, and I want to find the slope from 2 points, and we don't have a graph, there is a slope formula. Anyone, does that look familiar to anybody? M equals y2 minus y1 over x2 minus x1. Does anyone know why are there little 1s and 2s on those y's and x's? Do you know why those are there? Yeah. Yeah, that's kind of the order that they're in as coordinates. It's because if you look down, here's my first example. How many points do I have? I have 2 points. So how many x's do I have? I have 2 x's and I have 2 y's. That's just to show that we're talking about each of the y values and each of the x's. Okay, and then here in parentheses again I wrote, because I want to make you write it again, this is still, we're just doing the change in y over the change in x. Okay, so this formula we're going to use because taking these ordered pairs and then going and trying to graph them and do rise over run, that just takes too long. If I have to graph it myself, that always takes more time. I'm not going to do that. Okay, so to find the slope of this, what are my y values of these 2 points? Catherine. Say it one more time. 8 and negative 4. Now, do I have to write this? Do I have to do 8 minus negative 4 or negative 4 minus 8? It's a trick question. It doesn't matter. Okay, so it doesn't matter how you start. When I say take my y values and subtract them, what I always tell people is do what you think looks easier. So what would you rather do? Okay, 8, well, it's minus negative 4. Now, once I choose the order for my y values, I did 8 minus negative 4. What do I have to do for my x values? Do you think? Same order, which would mean what? 2 minus 5. I picked 8 to go first, or we picked 8 to go first, so it's Buddy has to be first for the denominator for the x's, okay? So for the y values, pick whatever you want to do, but then make sure you follow along that same thing for your x's, okay? All right. And I don't want to assume anything. Do you guys understand or remember why did I put the negative 4 in parentheses? Why? Yeah, it's purely to not confuse myself. I already have a minus sign there. I want to make sure I still realize that there's a negative sign on the 4 because it's very easy to miss that or to drop it when people plug these things in. Okay, what's 8 minus negative 4? It's actually 12, yeah, whoever said that. 2 minus 5 is negative 3. So this will really test. A lot of people get these wrong because they do them in their head, especially the negative stuff, and then we have, we just subtract them wrong. So be careful. What's 12 over negative 3 equal? Or just negative 4. Right. All right, guys, focus up, please. Okay, next one. Same thing. Same question. I'm going to find the slope. Somebody, anyone, can you raise your hand and tell us for the y values, what would you like to subtract, or how would you like to subtract the y values? What do you think? The good news is there's not a wrong answer to this. But, yeah. Wait, Morley.
10 minus 1.
Yeah, but I would rather do 10 minus 1 than 1 minus 10. So 10 minus 1 for my y values, which means what? What do my x values have to be? It's got to be negative 15 minus negative 3. So at least one part is easier, right? Because I can choose it to be that way. 10 minus 1 is 9. That's easy. What's negative 15 minus negative 3? It is negative 12 for a few of you that said that. What does 9 over negative 12 reduce to? What? 3 over negative 4. Since one number is negative, I'm just going to say negative 3/4. Okay, and again, you have to reduce them, otherwise they will get counted wrong. Okay, and that will be important as we move through the chapter to make sure that is reduced. Okay, last one on this page. Somebody, what do you want to do for the y's? All right, 8 minus negative 2 is the first thing I heard, which means what for the y, or for the x's, I'm sorry. It's got to be 7 minus 3. 8 minus negative 2 is 10. 7 minus 3 is 4. Does that reduce? 2. 5 over 2. And leave it as 5 over 2. Do not make it 2.5 or 2.5. Leave it as 5 over 2. And if you're saying or wanting to know why, or why would I do that, trust me for now. When we get to it later, when we have to graph stuff, it'll be better. All right, one last thing to do. Sort of, kind of, a little bit of a review. Pay attention, guys. We're almost there. Independent versus dependent variable. Which is which? Independent is the x, dependent is the y. Just like we talked about back in chapter 4. That's not changing. The dependent variable depends on the independent variable. If you ever read a problem and you're like, I can't remember, I'm not sure which one is which, that's what you're looking for. Okay, sounds kind of goofy saying it that way, but I don't know, it always kind of helps me. So this one says, the cost of 3 gallons of gas is $9.27. 7 gallons is $21.63. Identify the independent dependent variable, and then we're also going to find the rate of change. What's the independent variable in this problem? It is the gallons. What's the dependent variable? The cost or the money, right. And I'll give you a little hint. 99.9% of the time, if money is involved in the problem, that's your dependent variable. The money or the amount of money that I spend is dependent on how many gallons of gas that I get or put in my car. How do you think you would find the rate of change here? And again, I put in parentheses, this is the same as finding the slope. Trying to give you a hint. How would we find the rate of change? Anyone? What if... Okay, yes. I want to address that. Divide the cost by how many gallons. That would work for this problem. But will it work 100% of the time? No. So I'm not going to do it that way. I want to do just one way that will work every time. What if we thought of this like this, guys? 3 gallons cost $9.27. 7 gallons cost $21.63. What if I thought of those things as like points on a graph? Now do we know what we could do? The thing we just did, yeah, just use the slope formula now. Okay, we could do 2163 minus 927 over 7 minus 3. Okay, it's like we're finding the slope. It's the same thing as the rate of change. Okay, so what's 2163 minus 927? 12 point something. 36. And then 7 minus 3 is 4. And now since this one already has decimals in it, then I would just take this and just divide it out normally and get whatever I get. So what do we get when we divide 1236 by 4? 3, what? No, you don't. 309 is what you should get. Yeah, 309. 309 what? Dollars per gallon. Right. Guys, when you are asked to find the rate of change of a situation, it's like you're finding the unit rate. Okay? Now, unfortunately, it's not always, like we said at the beginning, it's not always just going to be division. Okay? Sometimes it's better off to do it this way. You'll get it right every time. Okay, that should do it.